So part of my role is to own our performance roadmap, own our scaling roadmap, and drive the technologies that go into all of our key performance measures. This includes fidelity. It includes qubit count. It includes working with the R&D team to think about how we're going to actually scale, being able to just think about how we design our ion traps, having multiple generations. Our early ion traps have heritage back to some of the national labs, but we've been doing individual investment in ion trap design over the last 5 years and more. And all of that investment continues to pay off and then open up capabilities that are going to increase our scale, increase our performance, and basically at the end of the day, deliver new capabilities to customers.
When IonQ thinks about improving performance for quantum computers, we're really trying to take a balanced approach. And the reason is simple. The reason is because we're interested in bringing the most value to customers as soon as possible. And so in order to do that, we need to balance a few key factors. So among those are qubit count, quality, as well as speed and connectivity. For qubit count, our architecture is all based around having qubits arranged in flexible packages such that we can move them around our architecture, photonically interconnect them when they're remote, in order to use kind of the most qubits, and that's pretty exciting.
And so what we're trying to do is provide a scalable, high-performant solution that actually is delivering value. And we believe that we're on the path to do that with our roadmap. We have investments in increasing fidelity, driving long chains to be able to provide the right balance between all-to-all connectivity, being able to drive the gate depth that we want through fidelity that we were trying to shoot for in those long chains, being able to drive scaling and trap architectures going from single core to multi-core and from multi-core to multi-QPU. That scaling strategy has been proven out. We're actively doing the engineering to do that. That scaling strategy allows us to take a balance between qubit count through time, fidelity, maintain fidelity while we scale, and then be able to deliver time to solutions at a price point that is actually going to move the needle to commercial value. And that's our fundamental approach.
This is one of the main reasons why we're a trapped ion quantum computing company, because in trapped ions, it's possible to get to those levels of gate fidelities. Those levels of gate fidelities have been demonstrated in academic labs. So we know that there's not a fundamental physical reason, and hence the job is on us to go and engineer the systems in order to reach the performance that we know is possible.
And so at IonQ, we've been on this journey for over half a decade. And we're continuing on this journey. We're moving from a physics and very heavily scientific organization into a product organization. That transition is all about being able to build something in a deterministic fashion for a customer, and not do it once, not do it twice, but do it 10 times, 20 times, 50 times. And being able to make sure that every one of those systems is going to produce the same performance with the same reliability, with the same overall scalability that actually just delivers value.